Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Today, inshallah, we're going to continue the topic that we did before, which is solving trigonometric equations. You have to remember the identities that we talked about before. We have two important identities, which is one of them is sine squared plus cosine squared is equal to 1. And the other one is sine over cosine equals to 10. These the two important identities that we're going to work them this year and even next year in grade 12. Okay, so remember that from the sine squared plus cosine squared, which is equal to 1, we can get two more identities. We can write cosine squared in terms of sine squared, and we can write sine squared to be in terms of cosine squared. So cosine squared is 1 minus sine squared, and sine squared is 1 minus cosine squared. Now let's solve this equation. This question is asking you to solve for the range from 0 to 360, which is in the basic quadrants: 0, 90, 180, 270, then 360. Okay. Now we're going to solve each expression, each bracket individually. For the first bracket, from this bracket, 2 cosine theta minus 1 equals to 0, and cosine theta plus 1 equals to 0. So from the first one, cosine theta is equal to half, and the other one, cosine theta is equal to negative 1. Cosine positive in the first and fourth, the expressions are theta, and in this quadrant, it's 360 minus theta because we're working in the positive range. And cosine negative in the second and third, expressions are 180 minus theta and 180 plus theta. Good. So theta equals to inverse cosine. We're supposed to find the reference angle, which is 60 here. Now we have to use them on the first and fourth quadrant. So theta is equal to 60, and 360 minus 60, we're going to find 60 and 300. These are the two angles when cosine has a positive sign and when cosine is equal to half. Now for the other one, theta, to find the reference, inverse cosine of 1. Don't use ever the negative sign. So inverse cosine of 1 is equal to 0. So theta equals to 180 minus 0 or 180 plus 0. So theta equals to 180 degrees. So it's only one angle, because whenever you replace 0 in one of these two expressions, you will get the same answer. See, in the same question, sine is equal to cosine. Simply, we can answer this question by dividing both sides by cosine. Dividing both sides by cosine. Why? To reach to the identity which says sine over cosine is equal to 10. So by dividing both sides by cosine theta, so tan theta on the left side, because sine divided cosine is equal to 10, and cosine divided cosine is equal to 1. Again on the same range. Tan positive in the first and third expressions are theta and 180 plus theta. So let's find the reference angle first. Inverse tan of 1 is equal to 45 degrees. Then theta equals to 180 plus 45, and 45 degrees, which lying in the first quadrant. So it's 2, 2, 5, and 45. We still in the same question. Let's do 8f 3 sine squared plus sine is equal to 0. I know we have two terms here. So we call this type of equations as a quadratic equation because you have power of 2. So what you're supposed to do first, you have to use the quadratic equation formula, or you can take out the common factor, only in this case. So just to remind you, this is like 3x squared plus x equals to 0. How did you solve that? You're supposed to take x as a common factor and only 3x plus 1 left inside. It's the same idea. So instead of the sign, you have x. Now you can solve it easily. Take sine theta as a common factor, then between the two brackets you have 3 sine theta plus 1 equals to 0. Once sine theta equals to 0 and once sine theta equals to negative 1 over 3. Based on the given range, sine positive in the first two quadrants and negative in the last two quadrants. But the point is, we couldn't say that 0 is positive because 0 is non-negative and non-positive. So what you're supposed to do, we have to find the reference angle, so theta equals to inverse sine of 0. Inverse sine of 0 using the calculator. Inverse sine of 0 is equal to 0. So it's only one angle. But the point is, how many angles will give you sine equal to 0 on this expression or this quadrant? 0, 180, and 360. All the angles on the same line will give you the same value of sine, like 0, 180 and 360. 90 and 270, same values of cosine. So cosine 90 and cosine 270 equal to each other, which is equal to 0. So here we can write three angles, 0, 180 and 360. Again, why? Because these three angles, sine of them is equal to 0. Sorry. Sine theta equals to negative 1 over 3. So sine negative in the third and fourth. So theta equals to inverse sine of 1 over 3. Let's find the reference angle first. Inverse sine of 1 over 3 is equal to 19.47. 19.47 degrees. Then theta equals to 180 plus 19.5, you just round it to one decimal place, and 360 minus 19.5. And you can find the angles by yourself. J, same idea of the question that we did in the previous part. Tan theta is equal to sine theta. So we know that tan is equal to sine over cosine, which is equal to sine theta. We can take sine theta to the left side and just do cross multiplying first. So sine theta equals to sine theta cosine theta. We couldn't cancel the sine with the sine. We're supposed to take sine as a common factor first, but you have to move that to the other side. So sine theta minus sine theta cosine theta equals to 0. Take sine theta as a common factor, so only 1 minus cosine theta is left. Now, based on the given range, sine once sine theta equals to 0 and once cosine theta equals to 1. Cosine positive in the first and fourth expressions are theta and 360 minus theta. So let's find the reference angle. Inverse sine of 0 will give you 0. It's the same idea of the previous question. So three angles, 0, 180 and 360. Now for cosine theta is equal to 1, the reference angle inverse cosine of 1 equals to 0. So whenever using these two expressions, sorry, theta equals to 0 and 360 minus 0. So theta equals to 0 and 360. As you see, 360 is repeated twice and even 0. So you can combine all of these answers into only three angles: 0, 180, and 360. Here is the answer. Question number 9. Solve for theta between negative pi to positive pi. Let's draw the range first. This range contains positive and negative range: 0, pi over 2, pi, negative pi over 2, theta, pi minus theta. So we have only the first two quadrants of the positive range and the last two quadrants of the negative range. You come back to the previous video to check that. So negative theta and theta minus pi. Now 3 minus 3 cosine theta equals 2. We're going to write sine squared to be in terms of cosine squared. We can write sine squared to be in terms of cosine, but we couldn't change cosine to be sine because that sine has power of 2. It's 1 minus cosine squared theta. You come back to the first point that we talk about on the first of this video, the beginning of this video. Expand the brackets. 3 minus 3 cosine theta equals 2 minus 2 cosine squared theta. Move that to the other side. 2 cosine squared minus 3 cosine theta. When you move 2 to the left side, you move it with a negative sign, so 3 minus 2 is positive 1 equals to 0. Multiply the first and the last term. 2 times 1 is equal to 2. Find out two numbers give you the product 2 and sum 3. So 2 and 1. 2 cosine squared plus 2 cosine theta minus, this is negative, it has to be negative, 2 cosine theta minus cosine theta plus 1 equals to 0. From the first two terms, take a common factor. The common factor that you're supposed to take is 2 cosine theta. So only cosine theta minus 1 is left. 2 divided 2, 1. Cosine squared by cosine is cosine theta. Negative 2 divided by 2 is negative 1, and cosine with the cosine cancelled. And take from the last two terms just the negative sign as a common factor. So you have cosine theta minus 1 equals to 0. We have two expressions now. Cosine theta minus 1 as a common factor and 2 cosine theta minus. So what is the number which is left here? It's 1 equals to 0. So we'll find two equations. Cosine theta equals to 1 and cosine theta equals to half. Cosine positive in the first and fourth and negative on the second and third, but we don't have negative. So for the first one, theta inverse cosine of 1. Inverse cosine of 1 is equal to 90 degrees. So whenever using that here, I know it's 90 degrees, but the question asks you that in radian. So if you want to write that to radian, 90 is pi over 2. So for this part, theta equals to pi over 2 and pi minus pi over 2. Then theta is equal to pi over 2 because two expressions will give you the same answer. For half, theta equals to inverse cosine of half. Inverse cosine of half is pi over 3. So it's two answers or two angles, theta and negative theta. So theta is positive and negative pi over 3. Now for the next question, sine to theta is equal to cosine to theta. We did the same idea before, but the only difference, you have a coefficient or a multiple with the angle. So first of all, we have to combine them to be only in one ratio. Sine divided cosine is equal to tan. So by dividing both sides by sine to theta. So it's tan to theta equals to 1. You have to change the range. Now the new range is from negative 2 pi to positive 2 pi. Now this is the new range. How many quadrants? Basically from negative pi to pi you have 4 quadrants. Now when you double 4 you will have 8. So we have all the positive range and all the negative range. 0, pi over 2, pi, 3 pi over 2 and 2 pi. 0, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Tan positive, first and third. Theta and pi plus theta. On the negative range, first is theta minus 2 pi, and here it's theta minus pi. So we did these expressions in the first video. 2 theta equals to inverse tan of 1, which is equal to pi over 4. Let's use them on the same expressions. So theta, which is pi over 4, then pi plus theta, which is pi plus pi over 4, then pi over 4 minus pi, which is lying in the third quadrant, and then pi over 4 minus 2 pi. And you have to divide all of these angles by 2. Theta equals to pi over 8. Then pi plus pi over 4 is 5 pi over 4. When you divide that by 2, it's 5 pi over 8. Pi over 4 minus pi is negative 3 over 4 pi. So negative 3 pi over 8. And then the last one, pi over 4 minus 2, is equal to negative 7 pi over 8 if you divide by 2. Here we go. This question is asking for solving with the same range from negative pi to pi on the same question, from negative pi to positive pi, which means we have to work a radian. 3 sine squared minus sine theta cosine theta minus 4 cosine squared theta is equal to 0. As you see, we have many unknowns, sine and cosine. I'm sorry, we have two unknowns, sine and cosine. So we have to write the equation to be in terms of only one unknown to make it easier to solve the equation. First of all, we're going to divide both both sides by sine theta cosine theta, the product of sine and cosine. See, we're going to do that. 3 sine squared over sine theta cosine theta minus sine theta cosine theta dividing sine theta cosine theta minus 4 cosine squared over sine theta cosine theta equals to 0. Squared cancel the sine with the sine, cosine with the cosine, and the squared with the cosine. Only one term left here. 3 sine theta over cosine theta, which is equal to 3 tan theta. Minus 1, nothing is left. Then 4 cosine theta over sine theta equals to 0. See, this is sine over cosine, which is equal to tan. So cosine over sine is reciprocal of tan, which is 4 over tan theta. So you're supposed to write tan because the starting of the rule is in the denominator, equal to 0. Then multiply the whole equation by tan theta. 3 tan squared minus tan theta minus 4 equals to 0. Tan by the tan is tan squared. Tan by 1 is tan theta. And tan theta by negative 4 over tan is equal to negative 4 without any tan theta, because tan will cancel tan. It's a quadratic. 3 times 4 is equal to 12. Find out two numbers, give you the product 12 and difference negative 1. So negative 4 and positive 3. 3 tan squared positive 3 tan theta minus 4 tan theta minus 4 equals to 0. It's a quadratic equation, by the way. It's exactly the same idea that we did in semester 1. From these two terms, take 3 tan theta as a common factor and only tan theta plus 1 left. From these two terms, take negative 4, so tan theta plus 1 equals to 0. We can take tan theta plus 1 as a common factor, then only 3 tan theta minus 4 left. Tan theta is equal to negative 1 and tan theta is equal to 4 over 3. Based on the given range, tan positive, first, third, negative, second and fourth. Expressions are theta, pi minus, and then theta minus pi and negative theta, because it's from negative pi to pi. For this, we're going to use first, second, and fourth. So theta equals to inverse tan of 1, which is equal to pi over 4. Then theta is negative pi over 4 and pi minus pi over 4. The angles are negative pi over 4 and 3 pi over 4. Now theta equals to inverse tan of 4 over 3. Let's use the calculator. Inverse tan of 4 over 3 is equal to 0.927, which is 0.93. Expressions, first and third. So theta equals to 0.93 and 0.93 minus pi. So 0.93 radian and 0.93 minus pi is equal to negative 2.21. This is the answer. Question number 10. Solve for negative 180 to positive 180. Now remember, you have double angle here, multiple of angle. This is question 10, by the way, into page 277. We're supposed to change the range first. How are we going to change the range? By multiplying the whole range by 2. So multiplying the whole range by 2, the new range is from negative 360 to positive 360. How many quadrants? We have 8 quadrants. The positive range and the negative range. Positive theta, 180 minus theta, 180 plus theta, 360 minus theta, negative theta, theta minus 180, and then negative theta minus 180 and theta minus 360. Sine squared and cosine, so we have to change sine to be cosine. We couldn't change cosine to be sine because that sine has power of 2. So using Pythagorean, 2, 1 minus cosine squared of 2 theta plus 3 cosine of 2 theta. Expand the brackets. 3 equals 2 minus 2 cosine squared of 2 theta plus 3 cosine of 2 theta. Now you have to rearrange the terms. We're moving all of them or just move 3 to the left side. It's negative 2 cosine squared of 2 theta plus 3 cosine of 2 theta, and then 2 minus 3 is negative 1 because that 3 goes to the other side with a negative sign. So minus 1. You can multiply the whole equation by negative 1. So it's 2 cosine squared of 2 theta minus 3 cosine of 2 theta plus 1 equals to 0. First, by the last, 2 times 1 is equal to 2. We need to factorize 2 because 2 is the product into 2 numbers, give you the sum of 3. So 2 and 1, both of them will take the negative sign. 2 cosine squared of 2 theta minus 2 cosine of 2 theta minus 1 of cosine 2 theta plus 1 equals to 0. From the first two terms, take 2 cosine as a common factor. So only cosine 2 theta minus 1 left. From these two terms, take only the negative sign as a common factor. So you have cosine 2 theta minus 1 equals to 0. You can take a common factor, which is cosine 2 theta minus 1, and the other expression is 2 cosine 2 theta minus 1 equals to 0. From the first one, cosine 2 theta equals to 1, and the other one is equal to half. Both of them positive, so we know that cosine positive in the first, fourth, 2 theta inverse cosine of 1. Inverse cosine of 1 is equal to 0 degrees. 0 degrees. Inverse cosine, let's make using the calculator. Inverse cosine of 1 is equal to 0. Yes. Then 2 theta equals cosine positive, I told you, in the first fourth. So 0, 360. You couldn't say negative 0, and negative 360. You divide all by 2, so theta equals to 0, and positive and negative 180 degrees. So we got 3 angles. Again, for half, so 2 theta equals inverse cosine of half, which is equal to 60 degrees. So using the expressions 60, positive and negative, theta and negative theta. 360 minus and theta minus 360 will give you exactly the same answer. You can write positive and negative. 360 minus 60. 2 theta equals to positive and negative 60, positive and negative 300. You need to divide both sides by 2. Theta equals to positive and negative 30, positive and negative 150. These are the angles. Question number 11. 9 tan power of 4 theta is equal to 1. You're supposed to divide both sides by 9 first, and the range is from 0 to 2 pi. Yes, it's tan power of 4 theta equals to 1 over 9. Take the fourth root. So the fourth root, tan theta, equals to root of 3 over 3, positive and negative. How are you going to do the fourth root in the calculator? You can do it in 2 ways. The first one, you can write the fourth root directly on the calculator. You have the option at the bottom, which you can use the power of any number or the root of any number, or you can do it twice as a square root. Square root of 1 over 9 is 1 over 3, and then the square root of 1 over 3 is 1 over root of 3, which is root of 3 over 3. On the range which is given to you, tan positive in the first and third and negative in the second and fourth. Expressions theta, pi minus, pi plus, and 2 pi minus. Theta equals to inverse tan of root of 3 over 3. Inverse tan of root of 3 over 3 is pi over 3. Pi over 6, sorry. We can make sure that we're going to change the calculator mode first, shift mode, and then we change it to radian, and then inverse tan of root of 3 over 3. The answer is 1 over 6 pi, which is pi over 6. So for the positive pi, this is for the positive sign and this is for the negative sign. Positive first and third, so theta equals to pi over 6 and pi plus pi over 6. The other one is pi for the negative, pi minus pi over 6 and 2 pi minus pi over 6, these two quadrants. So theta is pi over 6 and 7 pi over 6. Then this one is 5 pi over 6 for the first one and 11 pi over 6. This question, 3 cosine squared minus 13 cosine theta equals to 3 sine squared minus 9. Cosine, cosine, sine. We couldn't change cosine to sine, but we can change sine squared to be cosine. So 3 cosine squared minus 13 cosine equals to 3. 1 minus cosine squared minus 9. Expand the brackets and then combine the like terms. 3 cosine squared minus 13 cosine theta equals to 3 minus 3 cosine squared minus 9. Don't multiply 3 by the 9 because the 9 is outside the bracket. Now once you move that to the other side, 3 plus 3 is 6 cosine squared, and keep 13 cosine theta as it is. 3 minus 9 is negative 6. Negative 6 goes to the other side as positive 6. These two will give you negative 6. So when you move it to the other side, you move it as a positive sign. Then you can continue the question by yourself. Say by multiplying 6 by 6 is equal to 36. Find out two numbers, give you the product 36 and sum 13. So the two numbers will give you the product of 13 and the product is 36, 9 and 4. Both of them will take negative sign. So 6 cosine squared theta minus 9 cosine theta minus 4 cosine theta plus 6 is equal to 0. Take out the common factor. 6 and 9 will take 3 cosine theta is a common factor. Then 2 cosine theta minus 3 left. For these two, you can take negative 2 as a common factor. So you have cosine theta, 2 cosine theta minus 3 because you took negative 3 and negative 2 as a common factor. As you see, 2 cosine theta minus 3 as a common factor and 3 cosine theta minus 2. Cosine theta equals to 3 over 2 and directly this is rejected. Why? Because we know that the range of sine and cosine from negative 1 to 1, which means no angle with the sine or cosine, the values of them less than negative 1 or more than 1. 3 over 2 is equal to 1.5. So there is no angle for that. It's rejected. So only one value left. Cosine theta is equal to 2 over 3. In which range you're going to walk? On which quadrant? Cosine positive in the first and fourth. Theta and 2 pi minus theta. You can do it by yourself. Question. Eliminate theta from these equations. Whenever it's required to eliminate theta, which means you have to make theta and its ratio as the subject of the given expression. See, we're going to interchange the terms. We move cosine or move the 1 to the left side, it's up to you. Here, sine theta equals to 1 minus x. And if you move 1 to the other side, you'll have y minus 1. The only identity that you can work with to eliminate theta is the Pythagorean identity, which is sine squared plus cosine squared equals to 1. Someone will going to ask me why we couldn't use the other ratio, which is sine over cosine is equal to 10, because we didn't have tan theta. I know we can replace sine theta and cosine theta to be in terms of any other variable, but the tan, what are you going to do with the tan? You don't have any value for the tan here, so the only identity that you can work with is the Pythagorean identity. So sine is 1 minus x squared, cosine y minus 1 squared equals to 1, and that's it. This is the final answer without existing of theta. Question 13, proving identities. So this question based on all algebraic expressions and operations that we did them before. See, we have two sides on this identity, left hand side and right hand side. Identity, it's like the equation, but actually both sides supposed to be equal to each other. So let's start from the left hand side first. We're going to make common denominator. We're going to make common denominator, sine theta, cosine theta, by multiplying both denominators. Then using cross multiplying, cosine by the 1 is cosine theta plus sine theta times tan theta. Then Keep the sine theta, cosine theta as it is. Keep cosine theta. Sine squared over cosine. Why? Because that tan sine over cosine. So sine times sine is sine squared. And you couldn't multiply the denominator, by the way. You just keep the denominator. Then you're going to make a common denominator for the numerator part. This is cosine over 1. So you have cosine theta. Then you do cross multiplying. Cosine by cosine is cosine squared. And then 1 by the sine squared is sine squared over sine theta, cosine theta. This identity, we know that it's equal to 1 from the previous question. So it's 1 over cosine theta dividing sine theta, cosine theta. Denominator goes down. So you have 1 over sine theta, cosine squared theta, which is equal to right hand side. Here is the last question. It's the same idea of the previous question, which is proving. Prove that this is equal to 1. Starting on the left hand side, we're going to expand the brackets. I'll just remind you about the difference of two squares expression. X minus y, x plus y. If you multiply them, you will get the x squared minus y squared. Let's do the same thing here. So it's 1 over cosine theta all squared minus tan theta all squared. It's 1 over cosine squared theta minus tan squared, which is equal to sine squared over cosine squared. Because we know that sine over cosine is equal to tan. The common denominator is cosine squared. So it's 1 minus sine squared left and right. You can combine them. You shouldn't make a common denominator because it has common denominator already. 1 minus sine squared is cosine squared over cosine squared, which is equal to 1. Equals to right hand side. Thank you.